All right. We're live. So people start coming in. We'll give everyone about like a minute or two to join because we have a lot of good content to get through today, so we want to use all the time.
Awesome.
Plus, people will
By the
continue
way,
to trickle in.
is there any way we can see how many people we are, or only you can see that?
It should be at the top left, but if you can't see it, then maybe only I can see it.
No, I cannot see it. Yeah, it's
okay.
Fine.
I can share it with you after.
Hello, greeting.
Okay, so we have people joining us today from StreamYard, from LinkedIn, from YouTube, Twitch, and X. So thank you everyone for coming in. We'll go ahead and get started. So we have a really great webinar for you guys today. We have some demos that we also have prepared for you. So today we're going to talk about high performance multi-node GPU on DigitalOcean Kubernetes. That's what we mean when we say docked for anyone who's brand new here. And we're going to talk about setting up NVIDIA and AMD GPU clusters with RDMA. So I'm going to let our two speakers introduce themselves. But first, my name is Nicole. I've been at DigitalOcean for about 2 years. I'm the Senior Product Marketing Manager, and I work on the webinars, our sales success series. So Jeff, if you'd like to introduce yourself.
Sure. Good morning, everyone. My name is Jeff. I am one of the solution architects at DigitalOcean. I am based in Munich, Germany. Happy to say hello to you. British?
Sure. Thank you, Jeff. Hi, welcome everyone. And I'm a senior solutions architect as well. And I mainly work on AI/ML workloads. And I'm based out of California. Nice meeting you all.
Great. Okay. I'm going to hand it off to Jeff to begin our presentation.
Sure, of course. So just say hello again. Good morning. It is good evening here. My name is Jeff. I work for DigitalOcean for around almost approach to 3 years. And today we are going to talk about this setting up multi-node GPU clusters on Kubernetes. And you know what? I would love to kick off this webinar from a conversation that we had with the CTO of an AI model lab. We got a message from the CTO. They said, hey, our setup is working, but it's like slower than we expect. Is this normal? Is this normal? What do you think? I guess probably some of you may just nodding. Some people just don't know. You know what? This is actually pretty common questions, because if you go to the next slide, we will find out that it is actually that the RDMA wasn't configured properly. And when RDMA isn't really set up correctly, you know what? The system doesn't fail. It just falls back to the regular TCP/IP networking. So on the service, everything appears to work. No error message, no warning. The pods are running. The jobs are executing. But you know what? They were running 3 to 5 times slower than they should be. So just like the guy on the right-hand side, it is not working, or let's say not working correctly. This is the very scary part, especially for the multi-node GPU setup. You think everything is fine. You spend weeks wondering why your training is slow, and then you just don't realize that because it's just misconfigurations. All right, so today I'm going to show you how you can really set it up correctly, and more importantly, how you can verify that actually that is working. But before we jump into what you will get from this webinar, let's answer one question. Why do we really need a multi-node? Because the challenge is the memory. And if you look at the diagram on the right-hand side, you see the progression of the model size. The GPT-1 got around 170 million parameters. GPT-4 get you like trillions parameters. Let me give you a concrete examples. Like a 70 billion parameters will need around 140 gigabyte memory just to load the model weight. And do you think that H200 with around 141 gigabyte memory is large enough to squeeze that 70 billion parameter models into it? Technically, yes, but you got almost like a zero buffer, like for KV cache or no space for batching multiple requests. In practice, it is not stable. And what if, like GPT-4, if you really want to put it into a single GPU memory, a single GPU card, it is not really possible. So this is what we call the memory wall. So what is the solution? Let's go to the next one. The solution is actually the multi-node GPU with RDMA. RDMA stands for Remote Direct Memory Access. And with multiple GPU, it can break the single core memory constraint. And with the RDMA, it can enable the communication between GPU to GPU perfectly, like just bypassing the CPU. So with this RDMA being enabled, it can help you to improve the efficiency of your distributed training. And obviously for the inference, it can improve the time to first tokens as well. So let's go to the next one. So this is what you will get from the sessions. The first one, a complete setup workflow from set up a cluster to deploy the workloads. The second, the most excited part, the demo. And we have two demos today. The first one is the NVIDIA H200 demo. It will be a pre-recorded demo. It will show you how you can set it up from cluster to verify it. And then my colleague, Ritesh, will do the second live demo for AMD MI325X. And then it will all the way goes to verifications, whether to set it up, it is all the jobs be executed correctly, and also verify it is using RDMA for communications. Everything already be compiled into a package, so just put yourself in the back seat, and then we will send it over to you after the webinar. So let's go to the next one. So first of all, let's help you to understand these architectures, the technical architectures. On the bottom line, this is ROCE. It represents RDMA over Converged Ethernet. 8 interface per node. So from Fabric 0 to 7. And on top of that is the DOKS clusters. This is where that we have the GPU nodes and also Kubernetes control plane over here. On top of that is 3 very critical components. The mode of CNI, this is very critical. It will let us to attach multiple interface, like all 8 of the loose fabric connections. The second one, MPI operator, coordinate the distribute workload across nodes. And HPCX and UCX, just provide a high performance MPI layer. On top of that is the application layer, the worker pod, and also the NCCL or RCCL. The NCCL is for NVIDIA, RCCL is for AMD. This handle the GPU collective communications. So this is the tool that we will use to verify if we set it up correctly. I know it looks a little bit complicated, but once we walk you through from the 2 demo, and also you walk through this slide again after you receive it, you will learn by doing. So don't worry. So let's go to the next one. We have some glossary just to iterate through. If you see these acronyms, RDMA represent for remote direct memory access. Moto CNI is manage multiple network interface, and MPI is for multi-node compute task coordinations. Next one. So the setup workflow is consisted by 4 phases. First one, spin up the clusters from DigitalOcean's cloud panel, and phase 2 is a network configurations. Phase 3 is a workload deployment. Phase 4 is a pre-flight check. So let's go to the next one. So the first demo, NVIDIA H200 multi-node on DOKS. Let me give you an overview about the overall system setup. So on the left-hand side, this is the most critical part, the most important one, the hardware configurations. Just want to show you that we use 8 NVIDIA H200 GPU on a single node. And each GPU got its fabric interface for RDMA communications. And then we will use NCCL, NVIDIA Collective Communication Library, to verify everything is set up correctly. Okay, let's go to the next one. So without further ado, let's show you this demo.
Sorry, it just was made aware to me that you guys can't hear the audio, so let me pull this up. Give me 1 second. Okay. We'll try to play it through another platform. Okay. Sorry, I don't know why the audio isn't working, but let me figure it out really quick. I think I can pull up it on here. Okay, this should work.
Welcome everyone. Today I'll demonstrate how to set up multi-node GPU workloads on DigitalOcean Kubernetes using RDMA. This setup is critical for distributed AI training and high-performance computing workloads where inter-node communication becomes the bottleneck. We'll be achieving bus bandwidths around 400 Gbps across 2 H200 GPU nodes. Firstly, we set up the Kubernetes cluster on the DigitalOcean console. So once you go to the console, you see the create button and you click on the Kubernetes option, create Kubernetes cluster option here, and select the recommended version and choose the data center region as Atlanta. And we are going to need GPU nodes, and that would be NVIDIA H200. We are using DigitalOcean's managed Kubernetes with specialized GPU nodes here. They aren't just typical GPU instances, they're fabric contracted. So as you can see, the option that I'm selecting here, and we're going to be using 2 H200 nodes here. And let's have a CPU node. and you can read the cluster to and once you click on create Kubernetes cluster, the cluster would be created, and this is what the console looks like. So here you see the resources. So it takes a couple of minutes for the provision to take place. You can see that the 2 GPU nodes have been provisioned, and they are the GPU H200 nodes that are fabric contracted. So as the next step, let us save the kubeconfig and verify whether the nodes are ready for use. So you can see that kubectl get nodes shows the status as ready. So we have both the H200 nodes that are available for use. We will be referring the following README file throughout the demo. This guide provides the step-by-step instructions for running the multi-node RDMA workload. So we'll be focusing on running the distributed NCCL tests as an example workload. So as you can see, we have already created the cluster, and we have also verified that we have 2 H200 nodes that are ready to be used. The first step is installing the multi-CNI. Multi-CNI enables pods to attach to multiple network interfaces, providing direct access to high-speed, RoCE, or the InfiniBand. So let us install the multi-CNI here, and you can see all the steps, and let us verify the installation of multi-CNI. You can see the multi-CNI running. This verifies the step for installing the multi-CNI. Now let's move on to the next step, that is creating network attachment definitions. Why do we have to create the network attachment definitions? Here we need to define this host network devices to the pod level interface. So we have 8 fabrics distributed across all the 8 GPUs, and this needs to be exposed as a network definition to the pod interface. So let's go ahead and do that. Each network attachment definition is simple. It uses the host device CNI plugin type, which directly moves a network device from the host network namespace into the pod's network namespace. So let us verify the network attachment definitions are created. You can see that the network attachment definitions are created. Now, the third step is to build the Docker image. So this is substantial. It's about 8 to 10 GB that includes everything needed for high performance GPU communication, and it also has all the NCCL libraries. So here is the Docker file. Note that all these files will be provided as a resource after the end of the tutorial. And I already have a pre-installed image, since it takes about 30 to 45 minutes, and that's the reason why. Let us move on to the next step, that is the installation of MPI operator. Installing MPI operator is pretty straightforward, and we can see that once we apply this MPI operator, let us verify that the MPI operator is installed. It is running. So let's move on to the manifest file. Let's break down our MPI job structure here before diving into the YAML file. The launcher is where we run the MPI run. It doesn't need GPUs. It's just orchestrating via one launcher pod that will SSH into the worker pods and spawn our NCCL test processes. Workers are where the computation happens. We specify 2 replicas as you can see, the two replicas for the worker nodes here, and we specify the number of slots per worker, that is the 8 parameter that specify the MPI that each worker has 8 GPU slots available. When we run MPI run command, which is for the NCCL test, we are running with 16 GPUs, the parameter NP, which is distributed across the 16 GPUs. Each worker pod gets all the 8 fabric interfaces attached via the multi-CNI. Now we apply our MPI job manifest. So let's go ahead and apply the manifest. That would be NCCL test. So now we immediately start watching for pods with the second command, that is kubectl get pods. So we, like I specified, there is this NCCL launcher, NCCL worker, and NCCL worker 1. So until and unless both the workers are running, the launcher is going to fail, just to make sure the SSH setup is done on both the worker nodes. So let's monitor until both the workers are running. Now you can see both the NCCL test worker nodes, the two replicas are running, and let us wait until the launcher is running. You can see the launcher is running. So let's go ahead and check the logs of the launcher. Cool. Successfully we are running the NCCL test, and you can see that the bus bandwidth is above 450 Gbps. This NVIDIA's collective communication library provides the highly optimized primitives for multi-GPU and the multi-node communication. It's aware of the GPU topology and can make intelligent routing decisions. So let's wait for the test to finish. This verifies that the result or the internode communication speed is up to 487 or 491 Gbps. This concludes our test for the NCCL with multi-node capability. You can see that the average bus bandwidth at the end is 480 Gbps. Thank you.
Okay, thank you everyone for being patient. We had some technical difficulties, but I actually am going to have another demo for you guys, except this time it is live. So I'm going to bring Ritesh up here, and he is going to do a live one for you guys. We're going to talk about, again, multi-node on dock. So Ritesh, take it away.
Sure. Thanks, Nico. Welcome, everyone. Hope you enjoyed the first demo. So that was mainly focused on the NVIDIA GPUs. So let's move on to the AMD system setup. So here we are using the 8 GPUs of AMD MI325X, and each GPU has 256 GB of GPU memory and 8 fabric interfaces distributed across all the 8 GPUs. And these are the software versions: the Ubuntu 22.04, the ROCm drivers, and the RCCL test library. So let's get started. Let's move on to the next slide, and yeah, let's get started with the live demo. So let me share my screen. Okay, so hope you can see my screen. So this demo and the setup is very similar to what we did for the NVIDIA GPUs. So I already have the cluster setup, and in the cluster we have 2 nodes, and each node has 8 GPUs of AMD MI325X. So let's go ahead and verify whether we have all the nodes we need. Yeah. So as you can see, I have 2 GPU nodes and the 2 CPU nodes here, and all of them are in the ready state, and we can get started. So similar to the previous demo that we saw regarding the NVIDIA setup, we are going to need the multi-CNI. So again, the multi-CNI is where what attaches the network interfaces to the direct Rocky Fabric devices. So let's go ahead and install that. So you can see the status is unchanged because I already have it installed in my cluster. And let's verify the installation. You can see it's running. And let's move on to the next step. So again, it's the network attachment definitions. You may feel it is very repetitive, but it just shows how simple the setup is and how easily you can do the multi-node setup on our DOKS platform. So the network attachments here, this is the file that we'll be using. So this file shows 8 fabrics and how each network attachment definitions are exposed to the pod level interface. So let's go ahead and so I already have the network attachment definitions up and running, and that's why we see the status unchanged. And so this verifies all the 8 fabrics are visible. And let's move on to the next step. So again, we have this particular Docker file. So this Docker file is based out of the RCCL test GitHub repo. So we'll be providing this README file along with the resources needed after this webinar. And this Docker file has all the RCCL collective libraries, installed, and I already have built the Docker file, and I've also pushed it into our registry. So the next step would be installing the MPI operator. So let's make sure we have the MPI operator installed. You can see the status is unchanged, and which ensures that I already have the MPI operator running. So it's running, and so the final step would be we will be going through the structure of the MPI job here. So similar to the previous setup, we have one launcher pod, and this is where we'll be running the RCCL tests. And the RCCL tests will be based out of the 2 worker replicas that we have with 8 network annotations. And this is the Docker image that I've built based on the Docker image that I showed earlier. And this 2 worker pods sets up the SSH communication and SSH setup among the 2 worker pods or the 2 nodes of AMD MI325X. And the launcher pod launches the RCCL test with the NP parameter as 16, which suggests that there are 16 GPUs which will have the communication between them distributed across them. And let's go ahead and apply. So let's start monitoring the pods like we did for the NVIDIA test. So like I mentioned, until and unless there is this SSH setup between the 2 worker nodes, the worker 0 and the worker 1, the launcher pod keeps failing. And let's ensure. So we can see all the 3 pods are in the running status, and we can go ahead and look at the logs of the launcher pod. So the RCCL test is already running, and you can see in the logs that there is this 8 GPUs 0 to 7 from worker 0, and from worker 1 we have 8 GPUs again. So that ensures there is 2 nodes with 8 GPUs each of MI325X. And we see that the RCCL test is successfully running, and it takes a while for the test to end. So hope you enjoyed the tutorial. Thank you. And I'll hand it over to Jeff.
All right, take it away, Jeff. Thank you, Ritesh, for the demo. Jeff, you're on mute if you're trying to talk.
I'm sorry. Yeah. So everyone, I think that was a fantastic demo from Ritesh, and really, really awesome. So I think what we did today, we demoed 2 different GPU silicons setup for the multi-node, and also want to do a quickly recap of what we just go through. So there are 4 stages. The first stage is the class preparations, like how Ritesh click here, click there. Just in one page on DigitalOcean's cloud panel, you can spin up the multi-node DLKS cluster with GPU. The second part is the network configurations. Remember that Ritesh just apply the Moto's YAML file, set up those network attachment for the fabric interface, and also the MPI. After that, the workload deployment. This time we didn't really build a container because it takes around 40 minutes, but we have all those Docker file for you to just build a container, and you can deploy with the MPI operators. Last but not least, the pre-flight check, verifications, run the connectivity test to make sure RDMA is actually working. So the process is actually the same across both platforms, NVIDIA and AMD. And so I hope you enjoy this setup workflow. And I want to also quickly wrap up what we go through today. Let's go to the next one. Yeah, this one. Sorry, perfect. Yeah, this one. So when do you really need a multi-node GPU? The first reasons, memory constraint. Just like the first couple of slides, a single GPU can really hold a very big models. So you will need the multi-node GPU to aggregate all those memory to do the model parallelisms and also do the large batch inference. The second question, the second consideration, and the third one's for training, another one for inference. Both of them use them. If you use the multi-node for both of them, it will improve your efficiency, like training efficiency, and also reduce the latency. And maybe you will ask, like, when should we choose which type of the GPU? Let's go to the next one. So we can think about when should you choose different platform. There are 4 factors. Like think about that. The first one is about memory capacities. Like H200 got 140 gigabyte memory, and MI325X got 256 gigabyte memory. So it is different. And you also need to think about what you want to do on that GPU. The second is about the software ecosystems, like what library does your existing code use, and what is your team already familiar with. This is very important. So you don't have this ramp up period. You can just quickly just get started. The third one is about the workload type. Either it is training or it is an inference. Last but not least, you can I think you can guess is the budget, the GPU rental cost, but also the development and maintenance cost. maybe sometimes the cheaper GPU ends up costing more because you need more nodes or more engineering time. So just want to share with you like 4 factors about when should you choose what platform. And just before I wrap up, just want to tell that the good news is that DigitalOcean will support both platform, AMD, and GPU. So you can just choose based on your actual needs, not based on what cloud provider happens to offer. So that is my part. I will hand over back to Nicole.
Thank you. Appreciate that. Okay, so I just wanted to talk to you guys very quickly about DigitalOcean, if some of you guys are new here. So the question that you might be asking yourself amongst all the cloud providers and hyperscalers is why DigitalOcean? So for us, it really comes down to 3 things, as you can see here: simplicity, scalability, and approachability. First, simplicity. We make cloud infrastructure easy to use so that you can focus on building, not managing servers, applications, etc. And we have stats to back this up, as you'll see here for all of our points. Customers see 30% or more lower total cost of ownership, and they can set up their environments in half the steps compared to other cloud providers. So that is something that should not go past you, especially if you have a smaller team. Simplicity is something that can save you time, that can save you money. You don't need to hire another team member, additional resources, etc. And next, scalability. So whether you're just starting out or you are running and have been running a high traffic application, we grow with you. So we provide you the tools and the infrastructure that you need to scale your business as it grows. Our stats stand by this again. We have around 2 million droplets deployed, 221 petabytes of customer data, and 77 billion objects in storage. So customers have and continue to grow with us, grow their business with us, and their infrastructure grows as well. The last one is approachability. So building on the cloud should be easy. It should be easy for you, whether you are a curious developer or a C-suite executive. It should be built for everyone. It should be easy. It should be predictable. It should be well documented. It should come with resources. So at DigitalOcean, that's what we offer. We offer straightforward pricing, around 8,000 tutorials and 3,000 documentation pieces. And we also offer 24/7 support and an average response time of around 5 hours. If you'll excuse me really quick, just gonna get some of the background noise out. Okay, so next I want to talk about our global footprint. So DigitalOcean delivers reliable infrastructure and network connectivity to and uptime all around the world that businesses trust worldwide. So we have 16 data centers across around 9 regions, and we support over 638 customers, and that number is growing exponentially as we bring in customers, enterprises at the enterprise level, continue to help startups expand their footprint. And then lastly, we're in and around 190 countries. So our proven track record of uptime that is backed by our SLAs helps businesses scale and grow with confidence. So just wanted to show you our digital footprint, and below here you can see that some of the customers that we work with. Okay, so as Jeff mentioned, feel free to drop comments here in the chat, ask questions. If you have any questions about the demos that Ritesh went ahead and gave, please drop them here. And then also it looks like Jeff wanted to ask you guys, are there other topics around multi-node GPU that you would like our team to cover in the future? We can talk about cost management, specific workload patterns, production optimization, anything of that sense. So if you are live streaming, use the QR code, come on here and ask a question. If we don't have any questions, that's fine. I'll just welcome Jeff and Ritesh back to the stage. A couple of things I want to talk to you guys about. Our our migrations program, you can visit do.co/migrate, or you can use the QR code, scan the QR code. For eligible customers who are moving over $2,500 or more worth of workloads, our solutions architecture team will migrate you for free at no additional cost. And then additionally, you will get 6 months free of generative AI resources, our Gradient AI platform. So more about that on this website here, do.co/migrate, and you can scan the QR code as well. And then what to do next if you are looking to just try things at first. We do have an offer for new customers. Get $200 in credits to try DigitalOcean. That is our standing offer for new customers. So that is definitely something you want to take advantage of. If you have not spun up a DigitalOcean account yet, you can get started with Kubernetes that we talked about here. Get expert guidance if you want to talk to our solutions architecture team. People like Ritesh and Jeff, wonderful, knowledgeable, technical solutions architects that can help you, move over workloads, etc. If you have any questions for our sales team, then feel free to scan the last QR code. They can help you with anything related to our products. If you even, have a question on which product you should get started with for whatever project you have, they can help you with that as well. So I didn't see any questions. I think it's safe to assume that we didn't have any. So I will just assume that you guys are experts after these demos, if we have no questions, because of the wonderful demos that Ritesh gave. Ritesh and Jeff, did you have any last words or any closing remarks you wanted to give? No?
Yeah, of course. Very quick, but probably this is a question to Ritesh. Ritesh, I just remember that to the RDMA for multi-node, there are two types when you go for the cloud panel on DigitalOcean. One is contract, one is not. So if users want to enable RDMA, is there any other additional step they need to do?
No, it is pretty simple that they can directly choose the Fabric contracted option. So that should be available soon to everyone. And that option would enable people to just spin up the multi-node right away.
Oh, perfect. Yeah, because I know that some other cloud providers, they need to contact the support. So we already resolved that, right?
Correct.
Perfect. Yeah, I don't have any questions.
Okay. I just wanted to show you some kudos, Ritesh, that we got from your demo. Looks like we have a viewer on LinkedIn. Thank you so much. And it looks like we are being just brought up to time. So I will go ahead and end the webinar. And thank you guys. Don't forget, if you have any questions about this webinar, just scan the QR codes really quickly. Our solutions architecture team and our sales team are really great, thorough, technical people that want to help you get to the right place at DigitalOcean. So thank you guys so much. Thank you, Ritesh, for the demos. Thank you, Jeff, for the presentation. We appreciate it. We'll see you guys next time. Have a wonderful day.
Have a wonderful day. Bye-bye.
Bye.